Now we'll just move on and discuss this question 8.19 from the 10th edition of the book on vector mechanics by Beer and Johnston. In this question it is being said that a wire is being drawn at a constant rate from the spool by applying a vertical force P. This to the wire as shown. The spool and the wire wrapped on the spool have a combined weight of 100 Newton. Now knowing that the coefficient of friction at both A and B, now these 2 points A and B are given as 0.4 and 0.3 in static and kinetic cases respectively. Now determine the magnitude of this required force P. Now first feature of interest in this question is it is given that a wire is being drawn at a constant rate. So whenever it is said that a wire is being drawn at a constant rate, this means that there should be no external angular moment, because if there is some external moment or torque, then there will be some angular acceleration, and that angular acceleration will be defying the fact that the wire is being drawn at a constant rate. So when I draw the FBD, let me do it here. What I will be doing, just write W. Now this is actually known. W is equal to 100. Some force P is acting on a centricity of 0.75 mm. Now there will be some normal reactions, say N1, say N2, and there will be some friction involved. Now this force P is trying to rotate the cylinder in this anti-clockwise direction, and the ultimate aim of the friction is always to stop relative motion. That is why the friction at both these surfaces will be in the mentioned directions, okay, to stop the angular motion. What we want, that the moment applied by this P should equate the moment by these two things, these two frictional forces. Let me say that the larger radius is capital R and the smaller radius is small r. These also are known. Small r is known to be 0.075 and capital R is known to be 0.150 meter. Now there are actually three variables which are of interest here, that is N1, N2 and T. So we need three different equations. So that's very easy. First of all, whenever in a mechanics question you are able to draw the FBD correctly, the question is nearly done. Now just it is no rocket science to write the equations along three equations. One, the force balance along x-axis, another the force balance along y-axis, and the third the moment balance along the z-axis. Okay, so the force balance along the y-axis, first let me write it as W equals N1 plus mu N2 plus P. Okay, so this is the first equation, force balance along y-axis, that is sigma Fi is 0 because there is no net acceleration in the y-axis. Second, I'll try to write the force balance along the x-axis. That will give me mu N1 equals N2. Just see here, there is no force which is acting on the x direction except for these two forces. Is there any force? No. Mu N1 in this direction, mu N2 in this direction, all the forces are acting in the y direction. So this is the second equation, and I have obtained by sigma Fx equal to 0. Now again, the first thing I said in this lecture, we have to equate the moments, because the question demands that wire should be drawn at a constant rate, constant omega. This constant omega can only be achieved by no net external torque about 0.0, let's say. So the moment applied by this force P should be equal to the moment applied, resistive moment say applied by the friction forces, which gives me PR equals to mu N1 plus mu N2. This is the net friction, and multiply by the distance R. These three equations I have obtained. Now let us see how many variables are there. Weight is known, N1 is a variable, mu is known, and also I have already mentioned that mu we have to use 0.3, that is mu k actually, because there is some relative movement. So N1 is a variable, let's say N2, yes, it's a variable, P is a variable, P small r is known, capital R is known, mu is known. So there are only 3 variables, and these 3 equations must enable you to solve for the required force P.